Hi everyone, good day. Welcome to today's class. Today, I'm going to take you through correlation. One thing that you need to understand is that correlation is just association between two variables, but it does not necessarily mean causation. And when I say causation, it doesn't mean that one leads to the other. It's just a relationship that exists between two variables or two or more variables, but it doesn't mean that is one direct the other. That's not the case. It's a relationship between them. Get to know this. Because normally when we look at the cause and effect, some people think that once you run correlation and then you get your correlation coefficient, it means one factor is leading the other one to happen. That's not the case. So let's keep going. How do you do this? How do you run the correlation to get to know your correlation coefficient? There are two ways. So I'm going to start with the Excel, then I'll take you to the SPSS. So with the Excel, I'll go to data, click on data analysis, and then select correlation. And then when I click on OK, I have to just select all my data sets, which in this context, I'm just trying to look at the relationship or the association between leisure and study time. So first rows, and then I come to the outcome. And then I say, okay. Okay, so from here, based on the correlation coefficient, it seems that the relationship between the two is not that strong. Yeah, the relationship between the two is not strong, which can be seen from here. This correlation coefficient is 0.26. Normally, when your correlation coefficient is 0.2 to 0.2, depending on the criteria that you use, or 0.3, we consider it to be weak. And from 0.3 to 0.6, it's considered to be medium. And then depending once again on the criteria that you are using, if it's 0.6 and above, it's considered to be strong. But once again, there are two forms of correlation. So what I've shown is when it is positive, and I'm looking at it from the absolute values. When it is positive. When it is positive, when your correlation coefficient is positive, that means the two variables that you are looking at, they are moving to the same direction. In other words, as one moves up, the other one also moves up. When one comes down, the other one also comes down. Okay, positive. But when there is a negative correlation, that means that it's likely once one is moving up, the other one is also moving up. I mean, one is moving down, the other one is moving down, and so forth and so forth. And normally, when it is negative, we assume that there is an inverse relationship between the two. But if it is positive, we assume that there is a positive relationship between the two variables or the whatever variables that you are looking at. Okay, so always be guided by some studies, some threshold which have been agreed to guide you as to determine the correlation. Okay, so the correlation that we have just run is not clear. We don't know whether it's Pearson or Spearman because we want to know what is suitable for parametric data set. For parametric data set, it is recommended that you run a Pearson correlation. And then if it is a non-parametric data set, it is recommended that you run the Spearman's correlation. But normally, one limitation with the Excel is that it will not give you this distinction. So where do we get this distinction for? So I'll go straight to the SPSS where I can get these two. To do this, I'll just select my leisure and study time data sets, come and put them in the Excel, in the SPSS, and I will specify this is leisure. and this is steady time. Now, I know that these are not strings, but rather they are numerical values, so I need to specify these are numerical values. And then these are scale and scale as well. Okay, so here I want to run. How do I go about it? I go to Analyze, come to Correlate, and you select by Variate. The other types, which we will look at them in future classes. So I'll select both leisure and steady time variables, move them here. And then with the options, it's up to you as to if you want to make, but normally I suggest you keep the default. You just keep them. Then with respect to the correlation type, this is where you get to select the type of correlation that you want to run based on the characteristics of your data set. So here, I assume the data set is parametric. So if it is parametric, then Pearson correlation will be better. So I'll click on this, and the SPSS also give you the opportunity to know whether it's a two-tail or one-tail, because the SPSS has a way of also helping you to know whether your coefficient of correlation or the correlation coefficient is significant or not. So here I'll just go straight to the point, and then and just click OK. Yeah. So let's see what will come out. So what am I seeing? So we are getting the same results as we got for the correlation coefficient in the Excel 0.268. But here, let's look at the significance. Significance is showing that it's 0.96, and if it's 0.96, then we assume that depending on the hypothesis that you state. So if let's assume that our null hypothesis was that there is a relationship between the two variables, then we can say that indeed there is a relationship because it's greater than 0.05 or 0.01. Therefore, we reject the alternative hypothesis and accept the null hypothesis. But if our hypothesis was opposite and we said that there is no relationship or there is no association between the two, then once again we'll accept it. Okay, so it depends on the hypothesis that you state. But the correlation coefficient is there. It also gives you the observations, which in this case is 25. Okay, so that's Pearson. Now, what about if you assume that the correlation coefficient in this context and the data set in general is non-parametric? That means they don't meet the normality assumptions and then other assumptions relating to the parametric data set. If they don't meet, then we will consider the data set to be non-parametric. So for us to run that for correlation, we go to correlate once again by variate, and then they are already here. So this time around, instead of selecting Pearson, we'll select Spearman. Okay, and then you leave everything default, and then you click OK. Now let's see whether there is any difference. Okay, so I'm not seeing much, or I'm not seeing any difference between them because it's almost like we are getting almost the same correlation coefficient 0.28. And this 0.28, based on our threshold, just like the Pearson, they are low. They fall within the lower region, the threshold that I stated here. It's not strong. Yeah, the association between them is not that strong. It's weak. Let me put it this way, it's weak. Yeah, it's weak association or relationship. So it falls within here. So, but let's see whether they are significant. Once again, the significance will be based on the kind of null hypothesis that you have stated. If your null hypothesis says that there's no correlation or association between leisure and steady time, then here we meet it because here we have to accept the null hypothesis. But if it is opposite, you do the same. Okay, so thank you so much, and I wish you all the best. I'll come your way once again another time with another video where we'll go through other statistical analysis. Have a great time and see you soon. Bye bye.